Hi everyone, in this video we are going to learn about some more identities, and these are the sum and difference for cosine. We're going to have the sum and difference for sine and tangent as well, but those would be in 5.4. So sum and difference for cosine relates to values together, like if we have two different angle measures that we're trying to add together to get a different value, it relates them together. So that would be what they're equal to, that giant mess. And I'll show you in a second what those are all about. And we also have our cofunction identities. Basically, these just tell us that sine is equal to cosine when the angles are complementary. And, for all the rest, cosecant and secant and tangent and cotangent. Okay, so they're equal to each other when their angles are complementary, which we've kind of should have already know that based on a lot of the other stuff we've done. Like if sine equals 5/13, then cosine equals 12/13, like if you drew that triangle. So those values would be equal to each other. Okay, so when it's asking you to find these for cofunctions, just know that these are always going to be complementary. So that's how we can solve this equation. Theta plus 25 is always going to equal 90 because they're complementary. So that would mean that theta would equal 65 degrees. So what we're saying is that the cotangent of 65 is equal to the tangent of 25. So we can check and see if that's true, if we have the right answer, by just typing it in our calculator, which I think I'm in radians. Hold on. Okay, so if we type it in our calculator, the tangent of 25 is equal to 0.466. And the cotangent, remember, you would do 1 over the tangent of 65. So we get 0.466. So we know that those are equal. So we found the right measure. So they're equal to each other when their angles are complementary, when they add to be 90. Okay, so for this one we would do the same thing. So why don't you go ahead and pause and try to figure out example 2. And when you come back, I'll show you the answer. Okay, so I don't know if you can see I wrote in pencil on this one, but we did this plus this is equal to 90. So since that angle was negative, it ended up being an angle measure more than 90. So we got 120 for theta. And then when I checked, I plugged them back in and I got that they're both equal. So for there, again, we got that theta is equal to 120. Okay, so let's take a look at our inside and see what we're doing here. We're just going to start with this example on the right side. So this one says to evaluate cosine of 15. So what we're looking for here is an exact answer. We don't want decimals or anything like that. But 15 is not one of our special angle measures like 30, 45, 60. So we're going to use our sum and difference identities. So these identities tell us like we can add two numbers and take the exact values or subtract. So what two exact special angle measures can we combine either in adding or subtracting to get 15? So what one way, which there's multiple different ways, is I would do cosine of 45 minus 30. 45 minus 30 is still 15. Okay, so this turns into our angle A, and this is our angle B. And then we're going to use the formula to evaluate this. So it says that the cosine of A minus B is equal to the cosine of A times the cosine of B plus the sine of A times the sine of B. So we just plug our values in and then we just find what their things are. So the cosine of 45, that should be one that we have memorized. If not, you can draw your 45 triangle and find your values from there. So the cosine of 45 is root 2 over 2. The cosine of 30, we can draw our triangle for 30. The cosine of that is root 3 over 2. The sine of 45 is root 2 over 2. And the sine of 30 is 1/2. So once we plug those values in, we just multiply. So this would be root 6 over 4 plus root 2 over 4. They already have common denominators, so our final answer would be root 6 plus root 2 over 4. So that is our exact measure for the cosine of 15. So, you know, like the cosine of 30, we get root 3 over 2. Well, the cosine of 15 is root 6 plus root 2 over 4. If you have one of these calculators that give you the exact answer, it will actually tell you root 6 plus root 2 over 4 when you type it in, because it gives you the exact answer. That's not saying that I want you to use the calculator to figure it out. I want you to use the formula, but this calculator is smart enough to figure those out. So that's pretty much it. You'll see that it's really interesting that whenever we use the sum and difference for sine or cosine, the answers are just variations of root 6, root 2 over 4. So that's interesting. So why don't you go ahead and try the next one. If you're stuck because it's radians and you can't think in fractions, go ahead and convert that 5 pi over 12 to degrees and try to do it that way. Okay, so pause your video and try cosine of 5 pi over 12, please. Okay, so if we take a look at what we got here on this example, cosine of 5 pi over 12 is the same as cosine of 75. So I did 45 plus 30. And then in the plus formula, or the addition formula, it ends up being a minus in between. So that's why it changed root 6 minus root 2 over 4. So very good. If you have any questions about that, make sure you write it down to ask me in class tomorrow. But as long as you got that square root of 2 is negative and then the root 6 is positive, then you most likely did the right thing. So let's take a look at that example on the bottom. So this one is asking us basically to go backwards. So they gave it to us split up, and now we want to combine that and see what this equals. So since it has a minus in the equation, we know that that means that it's going to be cosine of a plus b if it has a minus. So this would equal the cosine of 87 plus 93. So if we add those together, we get cosine of 180. And then the cosine of 180 equals negative 1. So this is just equal to negative 1. And that's it. So moving on over here. So we're writing this in terms of just theta. So it says cosine of 180 minus theta. So we're going to apply our formula, this formula right here, plug everything in and see what we get. Okay, so cosine of a minus, or a and b, a minus b. This will give us cosine of a times cosine of b plus sine of a sine of b. So our a value was 180, so that's one that we can take the value for. So cosine of 180 is equal to negative 1. The one with theta, we just got to leave it. And since it's said in terms of theta, we're good. The sine of 180 is 0 times the sine of theta. So when we cancel that out, we just end up with negative 1 plus cosine of theta. So for this one, we lucked out. If there was a different angle measure here, it might not just, should just be cosine of negative cosine of theta. We could still have a sign there as well, but as long as there's no like angle measures left, then we know we got it right. Okay, so let's take a look at the top problem. So I think this kind for this section is one of the harder problems because we're using triangles and we're finding the values from triangles instead of finding them like based on the things that we know or unit circle. So it says to find the cosine of s plus t. So that s would be our a and t would be our b. So let's write out our formula first and then we'll worry about the rest of what they gave us. Okay, so cosine of s plus t or a plus b would be equal to the cosine of s cosine of t minus the sine of s, the sine of times the sine of t. So we just need to plug in what we have and then simplify that. So if we look at what was given to us, they told us the sine of s is 3 over 5. So that means I can plug that in here. And that the cosine of t is negative 12 over 13. So I know cosine of t is negative 12 over 13. But the issue here is I don't know the other two. Okay, and that's where our triangles come in. We can use our triangles to find them. So we're going to draw a triangle for angle S, and we're going to draw a triangle for angle T based on what they gave us, and they told us that they're both in quadrant 2. Okay, so here's my S triangle. So for angle S, and they told us that sine of angle S is 3/5. So sine is opposite over hypotenuse. And if we do our Pythagorean theorem, we get that the adjacent side is negative 4. Now we'll do for t, which is also in quadrant 2. And they told us that the cosine of this angle t is negative 12 and 13, so adjacent and hypotenuse. And if we do the Pythagorean theorem, we get that the opposite is 5. So we're missing the cosine of angle S, so the cosine of this angle S triangle would be negative 4/5. And then the sine of angle T, so the sine of this one would be 5 over 13. So from there, we just need order of operations and we're good. So we get 48 over 65 minus 15 over 65. So our final answer is 33 over 65. And that's it. Okay, so make sure you write down any questions you have and we can talk about them in class tomorrow.